Now let's get to the more interesting part. Convert metrics and log. How do you correlate them? The first basic problem is metrics are fundamentally numbers. Just numbers, billions and billions of numbers. Logs are English sentences, right? So if you want to correlate them together, they're apples and oranges, right? You cannot correlate them. Metric correlation itself is a hard problem, granted, but now you're looking at metrics and now you're looking at logs, who are fundamentally different classes of information. Some technology has to be built to unify them. Some common currency has to be built so that you can say, now I can compare these things. So let's see how do we do the metrics and the log stuff. So the metrics says, so this is the metrics pipeline. Like, how do we go from numbers into a color? So on the left is you have these numbers, and this chart that I'm showing is a latency chart as a data set. So latencies from point X to point Y, and these latencies have different numbers, and then we have to convert these numbers into good numbers or bad numbers, right? So for example, here, a number like 174 is still considered green, good. A number like 17, which is smaller than, is still red, right? So this is where the ML comes into play. It says that 174 is normal for this connection. However, 17 is not normal for this connection. 56 is, it's getting closer to being abnormal. So we generally have three colors, red, yellow, and orange, although orange and red are considered into the same category. So how does this baselining thing work? So there are two aspects to it. As and when data comes in, so you'll always see in the machine learning space, there is the training pipeline, which is shown at the top, and then there is the inference pipeline shown at the bottom. So the data gets fed into the training pipeline as well as the inference path. So the inference path is kind of lagging behind the training part. So the training part does its training, it builds its model, and makes it available to the inference pipeline. You can think of the model as a giant lookup store. Like, you just look up into it and you get a value back, although it's not as simplistic as that. So this model in the middle is continuously being built by the inference store. So as data is coming in, this training store is looking at data samples. It is going back in time. It is looking at whether the current data sample, what is the threshold value. It does all of that, and it starts writing into the model part. And then the real-time inference part is just comparing the computed threshold with the actual value and coming up with an answer, right? So if you it doesn't show up on this screen. So if you see the thing on the right, there is a faded line that is sort of the baseline of the chart. And then there are these spikes in the middle. So those spikes in the middle get flagged as red lines in the thing. So if you look at the behavior of the underlying metric, it's just a sea of greens, then a red, sea of greens, and a red. So that's the picture that I shown initially, that you had white things, which is just the numbers. And then because of this technology that we've built, those numbers get converted into red elements and green elements. Right? And another interesting part is the seasonality implementation over here. Because you know that, yes, it's going to spike up at a point in time, but that spike is normal. So there is a seasonality process which is running, which is looking at the numbers over a larger period of time, and it recognizes that morning 8 a.m., things are going to spike up. So it then artificially pulls up the threshold. Like, don't flag this as a red, because I've seen this happen. So we kind of look at seasonality as, if you look at your human brain, there is a system one behavior where you look at something and you instantly react, right? That's what the real-time baselining is. Seasonality is system two behavior, that you go back and you think about it, and that influences your behavior. That's a system two behavior. So this is how. So now we have numbers. We've converted them into events, right? Now we have a red event and a green event. So that's how we converted numbers into this common currency of events. We have to do the same process for logs.